Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Problem 19 asks you to describe Millikan's oil drop experiment and then relate that to how the electron's charge was discovered and why that charge is so important. So I've drawn a really crude representation of what Millikan's oil drop experiment apparatus looks like, but you can see a more detailed figure in figure 1.6 in your book. So essentially what the oil drop experiment involved was coating very small oil droplets, which were made very small by basically a bulb that just sprayed oil droplets into the air, and then passing them through this beam of ionizing radiation, which, as the name suggests, ionizes the air and releases these electrons. So the electrons then coated these small oil droplets, and using a very elegant microscope setup, Millikan could detect whether the oil droplets, which are usually neutrally charged, stop in this beam of ionizing radiation, so basically become neutral as far as their response to this electrical field goes. He had a positive plate on one side of this beam of ionizing radiation and a negative plate. And if you recall, like charges repel each other. So if these oil droplets become very, very negative, they move away from the negative plate. And if they're, very very moderately negative, then they stay closer to this beam of radiation, or slightly above it. And so by adjusting the strength of this electrical field to halt the movement of individual oil droplets, Millikan could measure the charge of the oil droplet and then use the properties of each droplet, such as its radius, to determine its overall charge, and then the charge of individual electrons by determining, using the size of this oil droplet, how many electrons might be on its surface. So using the radius of the droplets in concert with the charge of the droplets, by adjusting this electrical field, and knowing that the charge of an individual electron should be some whole number, he eventually came up with the charge of the electron as being negative 1.60 times 10 to the negative 19th coulombs, or a measurement of charge. Now, this charge is critical for basically life as we know it, because this particular charge is obviously enough to keep atoms intact, but it's conveniently not strong enough that chemical reactions can't occur such that electrons are rearranged to form new substances. So this experiment was really important in defining the charge of the electron, which is a fundamental idea in chemistry.